Okay, so in Unit 1, we talked about quadratic forms, and those were things that look like this: ax squared plus bx plus c. And surprise, surprise, it becomes a quadratic function when we put a y in front of it. Okay, so y equals f of x. If it has this form, it's a quadratic function. And we saw with the linear functions that they had two parameters, m and b. Here we have three parameters. We conventionally call them a, b, and c. It's a different b than with the quadratic function. Sorry about that, but I think you guys are getting used to the fact that these uh, variable letters get used for all sorts of things. Um, these functions, quadratic functions, are parabolas. Okay, so let's just go right away and look at some pictures here. Here's a picture of two quadratic functions. Okay, so again, as always, we've got y on the vertical axis, x on the horizontal axis. And the equation for this parabola is given here. And we can indeed see that we have a equals 3, b equals -6, and c equals 4 for this parabola over here, this one. And for the parabola over here on the right, we've got a equals -2, b equals 4, and c equals -1. So they both fit that form. They have this kind of shape. We're going to talk about their shape in quite a bit more detail once we have a little bit of calculus under our belts. One thing I will point out right now is that in this picture, you see we've got a as a positive number, and the parabola is opening upwards here. In panel B, a is a negative number, and the parabola is opening downwards. That's always going to be true. Okay, whenever you have an a that is greater than 0, the parabola is going to have this kind of shape. Opens upwards. We'll also be noticing that it has this turnaround point that's a minimum point. The cases where a is less than 0 is a negative number, like we have here. The parabola opens downwards. The turnaround point is a maximum. Okay, that really is more or less all I'm going to say about the shapes and how they relate to the parameters right now. But I do want to tie up a couple of loose ends that were left open in lesson 1 about factoring these quadratic forms. And in particular, I want to relate what we get from factoring an expression like this one. I want to relate that to the picture. Okay. So just thinking about one of the quadratic forms we worked with in, I think it was lesson 1C. I've got it graphed here, and I'll just remind you the equation was y equals x squared minus 5x plus 6. And that was one of the quadratic forms that we noted that you could use kind of the guess and check method to factor. We asked ourselves, well, what are the factors of 6 that might add up to -5? Oh, -2 and -3, that's possible. So we guessed that that expression might factor into y equals the product of x minus 2 and x minus 3. And when we checked that, that did indeed pan out here. So look at what we've got here with these two factors and what we see in the graph of this parabola. These factors we were looking for before because we wanted to solve the equation x minus 2, x minus 3 equals 0. And we noted that that had two solutions, x equals 2 and x equals 3. And just to refresh some nomenclature here. These expressions are the factors. So x minus 2 is a factor, x minus 3 is a factor, and these we might call the roots. Okay, the values of x that make the whole quadratic form equal to 0. The whole quadratic form here is what we're assigning to our y value when we make it a function. Okay, so what we have here are the 2 points where y equals 0, and that does indeed happen at x equals 2 and x equals 3. So when we find the roots of a quadratic form, what we are finding are the places where the function intersects the x-axis. Okay. Think back to the previous lesson when we were thinking about the linear functions, and that intercept parameter was the value where x equals 0. That told us where the function intersected the y-axis. Same deal here, that you have when you're setting one variable equal to 0, that's where the function is intersecting the other axis, is where you have no deviation from the in the other direction here. So that's kind of the graphic interpretation of those roots that we were finding in lesson 1. Okay, so far so good. What about one of those functions that we looked at just a couple screens ago? This is one of my example functions. We were talking about the whether the parabola opened upward or downward, and just reminding ourselves of what the equation is for that. It was y equals negative 2x squared plus 4x minus 1. Okay, that's not, doesn't look like a great candidate for guess and check factoring to me. I'm not really enthused about starting to just randomly guess here. The other thing you might notice is, okay, yes, it's crossing the y-axis at 2 points, but they don't look like nice whole numbers there. What could we do if we wanted to find out what those points were? I think I hinted in the previous lesson that there is an alternative to the guess and check method. Okay, so there's a formula called, word of the lesson, quadratic formula. Quadratic formula gives us the roots of any quadratic form ax squared plus bx plus c. So anytime we have that, we want to find the roots, we want to find the values of x that make it 0. There's a formula for it, okay? And this is the formula. X equals, it's a fraction, negative b plus or minus square root of b squared minus 4ac divided by 2a. This is the quadratic formula. Okay, it's kind of messy, but it's not that bad. So if we want to know the roots of that parabola we were just looking at, let's remind ourselves what it was. Y equals negative 2x squared plus 4x minus 1. Okay, so what do we have here? We have a equals negative 2, b equals 4, c equals negative 1. You do have to keep track of the signs here. So as always, when we're subtracting the 1, the way we think about that is adding a negative 1. Here. And let's just plug them in so that we get x equals negative 4 plus or minus b squared. Okay, so 4 squared is 16 minus 4 times A is -2 times C is -1. Look at all those negatives piling up. That's okay, we'll sort them out. And then down here in the denominator, 2 times A, that's 2 times -2. 2 times -2. Okay, fine. So that is -4 plus or minus, keep the 16. What do we have here? We have 3 negatives, that makes a negative. 4 times 2 times 1 is 8, so 16 minus 8 divided by -4. Okay, so that first term is just 1, -4 divided by -4. That's +1, plus or minus 16 minus 8 is 8 over -4. Sorry, it's not 8, it's the square root of 8. Don't let the square root go away. If I wanted to, I mean, I could just punch that out on a calculator. If I wanted to clean it up a little bit more, I might notice that I could factor the 8 as 4 times 2, and then factor out the 4 because it's a perfect square. So let's, and then cancel it with the 2. So let's do those last 2 steps just to make it a little bit simpler looking. Also, the plus or minus is going to take care of the negative in the bottom. We're going to be adding it once and subtracting it another. So this is 1 plus or minus, factoring out the 4 under the radical becomes a 2 because there's the square root. 2 times 2 squared divided by 4 here. So I get 1 plus or minus √2 over 2. Okay, fine. That I can punch out on a calculator. And let's see, I think I want to go back to the screen with the graph on it. Okay, here. So what we found here, found that we have roots 1 plus or minus √2 over 2. What can I say about that? 1 plus the square root of 2 over 2 turns out to be 1.71, and 1 minus that is 0.29. You can check that on your calculator. Let me know if you think I'm wrong about that. So what that's saying is that this parabola should intersect the x-axis at a little bit less than 3/4. Well, indeed, let's look. Here's 1, here's 2, this is 1/2, this is 3/4. That does look like that could be 1.71. That's one of its roots. And that the other one should be a little bit more than 1/4, a little bit more than 0.25. And indeed, that looks like what we've got here. Okay, here's the 1/4 mark, and it's just a little bit above that. So here's our 0.29. Okay. All right, so kind of a lot of detail here just to show that, yes, there is a formula that we can use here on any quadratic function if we want to find the places where it intersects the x-axis. If you want to find the values that will make y 0, same thing. We just plug the parameter values in to the expression, and we get the roots, and the roots are the places where the function crosses the y-axis. Okay, well, what about our other function in that picture that we started with? It was the one that opened upward. That function was y equals 3x squared minus 6x plus 4. Let's plug those numbers into the quadratic formula here. Okay, so the roots x will be negative b. Okay, so we've got a -6. The negative of that is a positive 6. 6 plus or minus b squared is 36 minus 4ac. So 4 times 3 times 4 divided by 2a divided by 6. 6 plus or minus 36 minus 48 divided by 6. Oh, dang, what's going on here? This is looking bad. I've got a -12. 36 minus 48 is -12. There is no square root of 12. 12 is a negative number. Nothing you can, no number you can square to get a negative number. Okay, so that seems terrible, or does it? Let's step back and think what this is telling us. Okay, what this is telling us is that there are no values of x that make y equals 0 for this function. And look, that's true. This function never crosses the y-axis. And indeed, this has no roots. Okay, so when we use the quadratic formula and we find that it's not giving us any answers that work, it's actually giving us an answer. It's telling us that there are no x values that satisfy it. And the last thing I want to, last quadratic formula example that I want to go over is this one. Okay, x squared plus 2x plus 1. You might be thinking, oh, hey, I don't need the quadratic formula for that. You're right, but just bear with me for a minute. We can use the quadratic formula. It should always work whether we need it or not. So for this function, let's find roots. X equal -b is -2 plus or minus b squared is 4 minus 4 times a is 1, c is 1 over 2a here. X equals -2 plus or minus 4 minus 4. Square root of 0 is 0. 2 over 2 equals -1. Okay, I just saw something wrong that I wrote before. You might be seeing it too. You might be noticing that this a doesn't need to be there. I'd substituted the a, so let's get rid of that. A equals 2 there. So what this is saying is that this particular quadratic function has only a single root. Now, if we had used just the guess and check method, or it wouldn't even really be guessing, we just might have remembered that x squared plus 2x plus 1, that's a perfect square. That's x plus 1 squared. And that does indeed equal 0 when x equals -1. Okay. And I'm just going through this example to show you that sometimes the quadratic formula can give you only a single answer. It gives you only a single answer when this plus or minus term under the square root sign is 0. Okay, so there's no plussing or minusing, you just get one answer there. And what does that look like? It looks like a parabola that just hits the x-axis at one point. At that point, x equals -1. Okay. Okay, so again, this factoring using the quadratic formula, mainly what I'm trying to help you do here is get increasingly comfortable with the algebra involving quadratic forms and polynomials in general. We use them a lot, but also just get familiar with those kinds of functions that we're going to be using a lot when we move to calculus. Okay. So we've got one more type of function to look at in this lesson, and then we will be on to the next step.